The story of Isaac Newton is really a brilliant one. There's so many facets to his life that are worthy of study. An incredible Englishman. But let's stick with some astronomy facts as it relates to the story that I'm telling you. What Isaac Newton did was remarkable because he did so largely with experiments of the mind. Now, at the time, he was a young 20-something, attending university at Cambridge. And there came a plague and a pandemic. Have we ever seen those before? And everybody was asked to disperse. Go back to your farms, get out of the city, because that's where you're going to catch this disease. And so Newton did so. But as he was leaving the university, he decided to sign out a few books, math books of all things, figuring with these 4 or 5 textbooks, I'm going to learn myself. And Newton was a brilliant individual. When he got back to the farm, and there was an apple orchard, the story is that he went for a walk, okay? And he went through the apple orchard, and he would have seen apples on the ground and apples in the tree. Now, of course, the legend is that an apple fell on his head and perhaps forced him into discovering gravity. But probably what happened was the apples were on the ground, and he realized that there must have been some force that caused it to go from the tree to the ground, and perhaps at the time looked up and saw the moon and figured that maybe the force that brought the apples to the ground was the same force that affected the motion of the moon. And so Newton decided to consider gravity to be the result of the interaction of masses, a large mass body and a small mass body. The larger mass body generating the greater force of gravity. The smaller mass body submitting to that force. And so Newton looked at gravity as like a long rope. And ultimately, without any math involved here, and there's plenty of physics courses that explains Newton's law of universal gravitation. But for now, let's just describe it. Newton figured that the force was proportional to the masses of the objects and inversely proportional to the distance between them. Okay, so if you're closer to the center of gravity, you'll feel the force of gravity greater, and if you're farther from the center of gravity, you'll feel the force lesser. In fact, by the inverse square law, so if you're twice as far away, you'll feel 1/4 of the force of gravity. If you're 3 times away, you'll feel 1/9 of the force of gravity. That's the law of inverse squares. We've seen that before with magnetism. So Newton felt that then this proportionality represented gravity. If the distance between the two objects grew infinitely, the force would diminish infinitely as well. But it would always be there. So gravity would be an infinite force growing more and more weak with distance. But he also felt that the force was instantaneous, meaning that if this gravitational rope between the center of gravity and the orbiting body were to be cut, then that orbiting body would fly off in a straight line, just the same as if I were to swing a bucket of water around and cut the rope. Then as I'm swinging the bucket and the rope cuts, the bucket would fly off in a straight line. Well, that was the way he concluded gravity to behave. It was like a pull to the center of gravity. Was he right? Well, there was one scientist who suggested that maybe Newton had missed a very important piece of the pie. And the person who figured out the error in Newton's work was Albert Einstein.